As you can see, I have a thing over here. It's not that important. Don't worry about it. Let me go ahead and timer. I'm not gonna start it just yet because I need to fix the audio because this thing, right, died yesterday. So now I need to reset the headphones to what they're supposed to be. Okay. And then we're gonna have some nice little jazz in the background. No copyright jazz. Da 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 da. It's under watch later. I think I caught it. Okay. Hello, hello. Hi, Troden. How are you? How was your day? I am pulling up our jazz playlist. There we go. And restart from the beginning. There we go. Did my camera change? Is that what you're asking? Did my camera change? Or what are you asking? I'm trying to figure something out. Okay, wait. I need to change the size of this. What are you trying to figure out, Cappy? Also, my camera did not change. What you're probably seeing is that. That is new. I built it yesterday because, I wanted to. There's not a thing. What are you trying to figure out, dude? What is the thing that you're trying to figure out? Let me turn it down a little more. There we go. And the yellow thing. This thing? That's been there. This has been there. This is my beanbag. I used it to sit on the floor. But I'll move it. It's not a big deal. I'll also move this. Ah! I'll break it before I move it, but I'll move it. There we go. It's not broken. It kind of still is broken. Wait. Hold up. I didn't start the timer, don't worry. There we go. Okay, we're good. I'll move this out of the way. There we go. Now it should look normal. Now it should be fine. I wish I knew how to help you, Cappy. I don't know what's going on, unfortunately. Anyway, we are here to learn about volcanoes. Yes, Cappy, have a Snickers. That will help. Unless, like, if there is a way we can help, please let us know. We want to help. But yes, we are going to be learning about volcanoes today. Is there a specific aspect of volcanoes that you guys are very interested in learning about that you don't already know about? Because otherwise I'll just start doing a crash course in volcanoes. Fault lines and fossils. Okay. So, volcanoes and fault line. Okay, so I've got a couple links here. Let me go ahead and switch to screen sharing. And then fossils. So we got fault lines and we got fossils. Those are our two big topics for today. That is something I should add, is like a little screen. There's the camera over there. On like this side. I could have just done that. Where it's like topics of today, and then it like drops down. Anyway, plate tectonics and volcanoes from the National Park Service, USGS.gov, plate tectonics in the Ring of Fire, Oregon State. There we go. We've got a couple things up here. Reject all. Looks at the relationship between plate tectonics, earthquakes, and volcanoes. If you look at a map showing the distribution of earthquakes, they tend to be concentrated along well-defined belts. Those being the tectonic plates, those fault lines. We can also see from the distribution of volcanoes around the world that most lie on plate boundaries too. Yep. In a particular region called the Pacific Ring of Fire on the edge of the Pacific Plate. That is... Oh, right there. Gotcha. The Hawaiian hotspot. There's just this one... There are a couple that are in random places, which is kind of interesting. I wonder how those formed. Tectonic plates are in contact... Oh, wait, shoot. Timer start. There we go. Tectonic plates are in contact with each other. They are also moving relative to one another. Pangea, yeah. Movement of fault. Well, no. Well, okay. I think what you're responding to is the thing about the random ones. These are just in the ocean. Like, they're just there. So I'm wondering if it could possibly be Pangea, or the other option is that it is from the deep sea vents getting so hot that they just, I don't know. Tectonic plates are in contact. They also move relative to one another. Yeah, that could be something we look up in a bit. The movement of fault at plate boundaries can provide a convenient pathway for magma to reach the surface. It helps to explain this by looking at 3 main types of plate boundaries: constructive, destructive, and transformative. Gotcha. So, constructive plates are moving away. Destructive, so it either goes down or up. And then transformative is just like... These are 3 things where volcanoes typically form in the hotspots. There's little or no magma available at the plate boundary. At constructive plate boundaries, the tectonic plates are moving away from one another. The Earth's crust is pulled apart and the magma flows up. Iceland lies on the mid-Atlantic ridge, where North American and Eurasian plates are moving away from each other. As the plates pull apart, molten rock rises up and erupts as lava, creating new crust. Some are extinct. That is an interesting way to describe a volcano. The majority of volcanism in Iceland occurs along volcanic rifts. Volcanism? Rift zones that cut through the center of the island. Wells up from deep in Earth's mantle. What is a hotspot? Is that just later on? It probably is. Yes, it is. So we don't need that. Destructive. Destructive or convergent plate boundaries are where the tectonic plates are moving towards each other. Where the oceanic plate descends below another or descends below a continental plate. This process is called subduction. Yes, duh. And creates distinctive types of volcanoes. Ocean produces an island arc volcano. Ocean continent produces Andean type volcano. Oh. Provides a mechanism for introducing water-bearing sediments into the mantle. As the subduct oceanic plate sinks and heats up, water is gradually released within the plate's slab. Water has the effect of reducing the melting pressure of the mantle by about 60 to 100 degrees Celsius. Melting temperature, sorry. There is a third setting of destructive boundary. Continent-continent here. The pushing together of 2 continental plates results in mountain forming. Yeah, that makes sense. Volcanoes can also form above a column of superheated magma called a mantle plume. This may happen in areas that are distant from plate boundaries. It is also referred to as a hotspot or intraplate volcanism. Okay. So that explains why there were some just in random areas. Heat from the mantle plume causes melting and thinning of the crust, which leads to volcanic activity at the surface. The Hawaiian Islands are a chain of volcanoes in the middle of the Pacific Plate, which have formed due to the presence of a hotspot. The Hawaiian hotspot causes magma to rise and erupt as lava on the ocean floor. The Pacific Plate has moved over the hotspot, creating a chain of volcanic islands. Oh. Plate tectonics. This is the next one. Okay, we just learned about that. Divergent plates and convergent plates. Volcanic activity occurs above places in the earth where pressure, temperature, and presence of water conspire to melt rock. Hot mantle rises, water flows through hot rock. The first type of melting occurs at divergent plate boundaries and hotspots. As the hot mantle rises, sudden drop in pressure causes melting. The second mechanism results in volcanism at convergent plate boundaries. As one plate dives, it heats up and releases hot fluids. Okay. Can you post a link? Absolutely. So when I will post all the links in the video, but I can also post them here. Let me go ahead and as I look at new ones, I'll post them in the chat. But every single thing, bro, be so serious with me right now. It's telling me to join Twitch today. I'm like, I'm literally the one streaming. Hello? Bro! Okay. I will get that fixed. Yes. Check your phone. Google sent a notification to your phone. Did you now? Yes, you did. Be so for real. Yes. Okay. Oh my gosh. That was an absolute load of nothing. Okay. So I cannot, in fact, send them in the chat right now. I will figure that out afterward. I do not know what's going on there. That's not good. But I will post them in the YouTube video that I post today. So, it will be uploaded. It may be a little bit, but I will get them to you. I do not know why Twitch has locked me out of my own chat room. That's really annoying, actually. Oh, wait, maybe. Shh. Let me go ahead and mute this. Big brain moment. Oh, hush. It will only be there for a second. Also, hello, King. Good to see you. And there we go. There are the two links. Got them. How you doing, King? Amazing. Whew. We got that figured out, at least. How is your day, King? Oh, please. The other option is DuckDuckGo. Okay. Plate tectonics in our national parks. We can look at that maybe later. Let me go ahead and over here. I'm not using Google. I'm not using Chrome. I'm sorry. Absolutely not. Brave, yeah. I just don't want to use it. It gets annoying sometimes. Wait, this dynamic world map of volcanoes, earthquakes, impact craters, and plate tectonics. Let's see. Here's the abstract. Over 1,500 volcanoes, 44,000 earthquakes, 170 impact craters. These features largely reflect the movements on Earth's major tectonic plates, and smaller placements or fragments. Volcanic eruptions and earthquakes are awe-inspiring displays. This map shows many of the features that have shaped and continue to change our dynamic planet. Oceans are continually opening, yep, or closing. Because continental... Hello! Hi, friend! Yes! Share the facts! We love to see it! Share the facts. They are. That is a good fact. Do you know why they're so big? Hey, Cappy, that's not nice. No, and I don't care to know. Oh, come on. That's the whole thing we're learning about today, is exactly how they get so big. We're learning all about volcanoes, how they form, and we're going to learn about fossils in a little bit. Possibly how, like, fossils found within igneous rock, which is what I'm assuming is implied by that. What we are looking at here... Whoa, there we go. Okay, these are a lot of different maps. There is an interactive map of all the volcanoes across the world, which I will go ahead and post really quick. There we go. All of these will be available on the video later. Oh, it also gives earthquake reports. Oh, that's so cool. Can I zoom in? You let me zoom in? Yes, you will. Amazing. 11 hours ago, and 22 hours ago, there were earthquakes in Mexico. Hey, Luna! Good to see you! Let's see. 18 hours ago, there was another earthquake in Colombia. Or was it the same one? Troden, you can attack. Whoa! Look at this mess. What is that? Where'd it go? Right there. What is that? Okay, wait. What are... Earthquake magnitude scale. Okay. 500,000 earthquakes? Millions of earthquakes a year? I guess that makes sense. Major earthquake, serious damage, great earthquake. One every year or two. It was insane. And weren't there multiple this year? Around the 5 to 8 range? That is a lot of earthquakes. Oh my goodness. And they're all in the 4 range, so I guess that falls under 500,000 a year. I guess it adds up. What do the scales mean? All unrest eruption. Oh, these are all volcanoes that are actively erupting. That is interesting. Cappy, can we help at all? Is there any way to help? Interesting. Michael Volcano is a young and frequently active stratovolcano. What is a stratovolcano? Composite volcanoes. Composite volcanoes are the most picturesque of all volcanoes. Okay, so that is just what we think of as a volcano. So I'm assuming the way that they get so big is because the magma's piling over and cooling off, but let's double check that. And hang on. My day is going good, Luna. How is yours going? Are you having fun? Doing well? Include volcanic ash, but no incorporate, incorporate no magmatic material. Okay. Day's good. Awesome. Good to hear. We are learning all about volcanoes today. Hydrovolcanic eruptions build tough rings in Mars, such as a group of craters in Death Valley National Park. They've also occurred in the summit of Kilauea in Hawaii Volcanoes National Park. Okay. So these are... Okay. And then magmatic is the... For composite volcanoes to get so big. Hundreds of thousands of years through multiple eruptions. Some, but not all, earthquakes are related to volcanoes. Most earthquakes are along the edges of tectonic plates. Right. Most earthquakes directly beneath the volcano caused by the movement of the magma. The magma exerts pressure on the rock until it cracks the rock. Then the magma goes into the crack and starts building pressure again. Okay. So some earthquakes are literally caused by just volcanic forming. So we can close that. The Ring of Fire. Okay, so it's just the name of where most of the activity happens. That makes sense. Tectonic plates, conversion plates. The Aleutian Islands in the U.S. state of Alaska run parallel to the Aleutian Trench. Both geographic features continue to form as the Pacific Plate subducts. Andes Mountains run parallel to Pure Chile Trench. Transform boundaries, hotspots, active volcanoes. Okay, so that's all stuff that we have read before, but I will still link this. Let's see. The effect of fault systems on volcanic activity. Hold up, hold up, hold up. We got something good. We got something good. Let's jump over to 2. This is Science Direct, which means that this is an actual research article. This is good. This is good. Okay. No, reject all. We don't want any of that. Structural geology provides valuable information from understanding the magmatic processes associated with the rise of magma and the presence of volcanoes. The VTMBF is a group of quaternary monogenic volcanoes settled in an active fault system, which allows us to propose the role that these faults play in the volcanic activity. This is located near Manizales, Colombia, on an active fault system at the western flank of the Cordillera Central in the northern Andes, or the Cordillera. It's characterized by andesitic lava domes and flows, which individually reach volumes. This works usually geometric and kinematics of the faults. Okay, wait, I actually need to lock in and pay attention here. Okay. Okay, so this field is characterized by the lava domes and flows, which reach 2.5 kilometers cubed. This works geometry and kinematics of the faults. New and published ages to evaluate period of volcanic activity were identified here, northwest, southeast. Okay. Fault kinematics are dominantly normal. This supports the presence of different emplacement mechanisms related to both the movement and the strike of some faults and the intersection between faults. Okay. The pauses of volcanic activity could coincide with the absence of structural conditions, such as interseismic cycles for faults, to facilitate the rise of the magma. Okay. There's no clear spatial or temporal pattern of volcano distribution within the field. There is evidence of seismic activity in the area, thus the future formation of dilating zones that allow the magma to rise and the emplacement of new monogenetic, yes, I said that right, is feasible. Okay. That's a lot of science words. Let's try to break this down. I wouldn't even know where to begin, actually, in breaking this down. Okay. So it looks like fault interactions controlled the emplacement. Okay, so literally just gotcha. Okay, that was the thing we read about before. This paper presents the relationship between monogenetic volcanism and the faults of the area through the proposal of mechanisms based on a characterization of kinematics of the faults and the results of eruptions ages of some of the volcanoes that compose the field. In northwestern South America, form a complex tectonic... Oh, it doesn't show the whole thing! Oh, that's annoying. Oh, it doesn't show the whole thing. We do have an abstract, though, which says that there is some, why am I blanking on the word? Correlation between volcanic activity, magmatic activity, and fault lines. So that's pretty cool. And the pause of volcanic activity can coincide or is correlated with the absence of structural conditions, which, what are interseismic cycles for faults? What is that? Shh. You figured it out! Okay, yay! What was going on? Let me in. No. No info. Okay. These are a lot of words that I do not have anything. We show that differential interseismic velocities may reach local rather than far field maxima, contributing to suppression of apparent slip deficit rates. Do any of you know what that means? Because I don't know what that means. Okay. We are learning all about volcanoes today, and somebody suggested looking at the relationship between, Troden specifically suggested looking at fault lines. So we started with just looking at the plates and how volcanoes actually erupt and how the tectonic plate shifting can impact volcanic eruptions. But then when we were looking at specific things like over here, we were looking at the Michael volcano. That spiraled into, okay, well, this is a stratovolcano. What's a stratovolcano? We looked that up and it showed this. And then we looked into further, just like, how long does it take for them to get so big? And then that brought us to a different place, which had us looking at interseismic cycles for faults. And then we found a bunch of different scientific articles that I will absolutely link to. I am trying my hardest to understand what these mean. However, I'm pretty sure in order to understand some of the scientific, what's it called? Oh my goodness. Not verbiage, but underwater volcanoes. That is a good question. I'm assuming it is something similar, but let's look up underwater volcano formation. No, we don't trust that. Woods Hole Oceanographic Institution and Global Foundation for Ocean Exploration. Let's look at that. Okay. What are volcanoes? Where do volcanoes form? Subduction zones. Spreading centers. Placed on the planet where tectonic plates move away from one another and magma rises up to fill the gaps. Okay, we saw that before. That was the distancing. Geologists in Iceland have warnings that, no idea what that says, may have been ramping up for an explosive event in December 2009 when swarms of tiny earthquakes shook the volcano. Why are volcanoes important? Short and long-term risks. Are lahars and pyroclastic flows. Both are superheated mixtures of water, gas, dust, and rocks that cascade down mountainsides and river valleys and around obstacles, burying or incinerating virtually anything in their path. They often move quickly, faster than a person can run. Okay, what is the difference then between lahars and pyroclastic flows? What is the difference? Shh. Okay. Lahars is an Indonesian term that describes a hot or cold mixture of water and rock fragments. Lahars can occur with or without volcanic eruption. Eruptions may trigger lahars by melting snow and ice or by ejecting water from a crater lake. Pyroclastic flows can generate lahars when extremely hot flowing rock debris erodes, mixes with, and melts snow and ice. Okay, so the pyroclastic flows are the magma flows that we typically think of coming out of volcanoes, whereas lahars are like water streams full of rock and sediment. Okay. Cool. Let's go back to underwater volcanoes. There was nothing about underwater volcanoes. I'll still link it, but an explosion at the West Mata volcano. Volcanoes are common occurrences along the boundaries of Earth tectonic plates. Okay, it looks like just underwater volcanoes are volcanoes that form underwater. Since the plates, let's go back to that map. Do we still have the interactive map? Michael volcano, we do. So, since the plates... It doesn't show the plates. Oh, that's annoying. Tectonic plate division. Images. There we go. Since a lot of the tectonic plates, you can see kind of here, run underwater, likely underwater volcanoes are mostly associated with that. And since water is where... Yes, geography. Well, no, not geography, but geology. You don't need to know, like, all of this specifically. It's just a matter of, oh, yeah, the fault lines and the tectonic plate edges are, a lot of them are underwater. So when that magma comes out, it's going to be underwater, which means that that volcano is going to start underwater, and then over hundreds of thousands of years, it's going to build up and up and up and up and up until it gets to be so big that it doesn't even need to be underwater anymore. Now, some of them are going to form on land, as shown by these and these, but the vast majority are going to form underwater. So, and then they're going to work their way up. So yeah, that is what these websites point to. And then this was really cool to see. Yeah, let's look at images of... Oh, we got more. We got more. We got more. Ow! Okay, well, Wiktionary says it's between seismic events. Okay, that makes sense. But we're still going to look at whatever interseismic coupling, asperity distribution, and earthquake potential. We're probably going to look at that. Tell them you're listening to someone learn all about volcanoes. Look at that, plain language summary. We'd love to see it. In the period between earthquakes, crustal faults are either partially to fully stuck or slipping freely. In the former case, plate movements can cause a buildup of energy and eventually be released. Using global positioning systems to measure the movement, we can use models of crustal deformation to identify where and how quickly faults are accumulating energy, and then making reasonable predictions about the locations and magnitudes of future earthquakes. That's really cool. That's really cool. So basically what they're doing is they're trying to measure that period between earthquakes to eventually predict when earthquakes will happen. When was this written? This was 2023, so very recently. Okay, well, kind of recently. If there's one thing to know about research papers, whenever it's published, they did all of the research for it at least 1 year ago. So this research was done in 2022. Cool. And they're doing this out of Tibet. Okay. I will link this. That is a really cool premise. The accumulated energy can produce earthquakes of 6.4 to 7.7. Okay. And now I'm curious. Major earthquakes in southern China 2024. Were there any? Look at that. Oh, wait, that's the southern sector of northwestern China. Taiwan. There we go. So they got it. They got it pretty spot on, too. 7.4, and they were predicting somewhere between... Where was it? That's not the right one. Where was the one we were looking at? We weren't looking at that. We weren't looking at that. There we go. They were... This was not it either. We got so many scientific articles up. This is great. Plain language speak. There we go. That's also not... There! 6.4 to 7.7. There we go. Yeah, that's crazy. The study used GPS measurements. Yeah, they got that. Good for them. That's really cool. Decadal variations in interseismic deformation rate. By Harvard. While that's loading, let's do something new. Fossils found in volcanic rock. Volcanoes and fossils. There we go. Explosive fossil fruit. That is an amazing tagline. Like, headline? The majority of all fossils are found in sedimentary rock. In rare instances, fossils are preserved in some volcanic rocks and deposit. Volcanic regions tend to be teeming with life because volcanic soils are fertile. That is another. Why are volcanic soils often very fertile? We will look at that after these. Depending on how explosive an eruption is and the composition of the magma, volcanic eruptions may produce either lava flows or fragmented volcanic material known as tephra. Fragmented volcanic material known as tephra. Fossils in lava flow are quite rare and generally restricted to molds of trees that were enveloped by advancing lava. Fossils are more likely to be present within tephra deposits. During vigorous eruptions, tephra may be propelled tens of thousands of feet into the atmosphere. The smallest particles may form ash clouds that are dispersed great distances by winds prior to falling to the ground. We have seen that before, not on this channel or anything, but there have been fossils preserved by ash, and that is, yeah, yep, right there. They accumulate so it can preserve the remains of plants and animals in their deposits. Due to their high temperatures, lava flows typically rapidly incinerate organic material. Therefore, fossils are rarely present in lava flows. Lava flows erupted on volcanoes such as Kilauea in Hawaii Volcanoes National Park frequently engulfs forests. Upon surrounding the trunk of a tree, the lava surface is chilled and can sometimes make a clear mold of the tree's bark. You can see that right there, actually. That's really cool. Lava tree molds are documented in all of these places: California, Hawaii, New Mexico, Idaho, and Hawaii again. Volcanic mudflows known as lahars are a particularly common feature of composite volcanoes such as Mount Rainier. They're mixtures of water, volcanic ash, tephra, rock fragments, and chunks of ice. Ice! That's crazy. But yeah, you see that? That's a good image. Lahars travel down river valleys and may bury trees and forests under great thickness of volcanic mud. Petrified wood is the most common type of fossil in lahar deposits. Fluorescent Fossil Beds National Monument. Lahars are the key component of the geological history of Fluorescent Fossil Beds National Monument. John Day Fossil Beds National Monument. Okay, now it's just a bunch of monuments. Volcanic ash may contain important fossils. Volcanic ash is fine-grained material, less than 2 millimeters across. Shattered bits of volcanic glass, crystals, and rock fragments. Since volcanic ash is mostly made of glass, it provides a ready source of silica, which is important of the fossilization process. Diatom blooms. The presence of silica from volcanic ash is indirectly responsible for many exquisitely preserved fossil insects. Lake Florissant formed after lahars dammed a river. Continued volcanic activity periodically washed volcanic ash into the lake, where the presence of silica resulted in blooms of diatoms, a type of microscopic algae with cell walls made of silica. That's really cool. And it is tiny, too. Oh, look at that. There's more fossilized algae. Algae? Look at that. That is beautifully preserved. Oh my goodness. Cappy, I hope you're seeing this. I hope you're looking at this, because this is cool. Heavy ashfall, even from volcanic eruptions far away, led to the death of prehistoric animals due to the inhalation of ash. The animal carcasses can then become entombed in ash. Ashfall Fossil Bed State Historic Park, a national natural landmark in East Nebraska, is a classic fossil locality containing fossils and ashfall deposits. A massive volcanic eruption 900 miles west in Idaho nearly 12 million years ago ejected voluminous ash into the atmosphere where wind blew it east. At Ashfall Fossil Beds, the layer of ash from this eruption is approximately 8 to 10 feet thick, encasing articulated skeletons of ancient horses, camels, and large rhinos that perished while breathing the abrasive ash. Oh, look at that. So the ash eventually becomes part of the sediment. That's pretty cool. And sedimentary sequences contain minerals which enable the determination of their numeric age. Minerals such as zircon and feldspars contain radioactive elements which can be used for dating. Carbon dating. Or not carbon dating, but yeah, geologic clocks. If volcanic ash contains fossils, it can be used to infer the age of the fossils. Hagerman Fossil Beds National Monument. Petrified Forest National Park. National Monument. Look at that. You can see the layer. That's so cool. This will, of course, be linked. I will also go ahead and link it in chat now before I forget to. There we go. Explosive fossil fruit found buried beneath ancient India lava flows. That is a great headline. Before the two landmasses merged, India rafted over a hotspot within the Earth's crust, triggering one of the largest volcanic eruptions in Earth's history, which likely contributed to the extinction of the dinosaurs. In a recent study published in the International Journal of Plant Sciences, link, they excavated the fossilized remains of plant materials wedged between layers of rock, describe a new plant species based on the presence of distinctive fruit capsules that likely exploded to disperse their seeds. There are plants that currently do this, which is really cool. There are plants that do explode to disperse seeds. The fossils may be the oldest fruit discovered to date of the spurge family. What? Oh, interesting. Poinsettia, castor oil, rubber trees, and crotons. Just to get an idea of how different these are, let's look at poinsettia. Right? We all know and love the poinsettia. Rubber tree. Like actual rubber tree, not the figs. Rubber plant. And crotons. What are crotons? Huh. So that is like your stereotypical houseplant family. Interesting. We already looked at that link. The fossilized fruits were discovered near the village of Malgaon Kalan in central India, where the remains of the once widespread volcanic rock lie just beneath the surface in a complex mosaic. You can walk around these hills and find chunks of chert that had just weathered up through the topsoil. Some of the best collecting is where farmers have plowed the fields and moved the chunks to the side. For paleobotanists, it's like finding little Christmas presents along the edge of the fields. The volcanic eruptions are thought to have lasted for up to 1 million years, occurring in prolonged pulses that blanketed the surrounding landscape in thick lava layers up to a mile deep. That is a lot of explosion. That is a lot of eruption. Today, the basalt rocks left over from the eruptions, known as the Deccan Traps, cover an area larger than the state of California. Crazy. The most violent of the volcanic events, which occurred at the tail end of the Cretaceous, may have been triggered by the asteroid impact half a world away. The impact in the Yucatan may have caused seismic perturbations that actually disturbed the regime on the other side of the planet, causing lava to erupt. Sandwiched between the basalt, paleontologists have found shales, chert, limestone, and clays stacked in a giant layer cake of alternating bands. These fossils provide a glimpse into what seems to have been relatively calm periods of stability between massive lava flows. They were likely shrubs or small trees that grew near hot springs created by the interaction of groundwater with naturally heated rock beneath the surface. Look at that. It looks like it's going to explode. Petrified wood is a common find in the Deccan Traps. Most have small diameters, suggesting a lack of large trees whose conspicuous absence have stumped scientists trying to stitch together the ecological history of the region. Maybe because it has been exploding for 1 million years, they couldn't grow that big. Just a thought. It's unclear why the trees were unable to obtain greater stature, but Manchester suspect the underlying basalt may have restricted the growth of the roots. That's a good thought too. Again, alternatively, the plants may have been part of the young forest that grew in volcanically active regions. That's what I said. That's what I said. Fruits from the new species were found pristinely preserved in a matrix of chert by the co-author. Ow! Sorry. But with only the fruits to go on, determining which plants they belong to required a significant amount of investigative research. Look at that. That is cool looking. The orientation of fibers inside the fruit indicated they were likely explosive. Yeah. Once the fruit in these species had ripened, they began to dry out, losing as much as 64% of their original weight, which built up tension in the rigid outer layers. You hear this loud pop, and the seeds and pieces of the fruit go flying everywhere. We think this is the case for these two fossil species as well, because we see the same anatomy where the fibers in the inner and outer layers of the fruit wall are oriented in opposing directions, which helps build torque. Yeah, see? Look at that. Just scatters its seeds. We don't need to see exploding watermelon. That is AI. But yeah, you can see the way it looks. That's crazy. By the time India finally slammed into Eurasia, 10 million years after the extinction of the dinosaurs, it had given rise to an incredible diversity of life found nowhere else. It's likely the first grapes evolved in India, as did the ancestors of whales. Huh. Pitcher plants, flightless birds, lizards, freshwater crabs, scorpions, and praying mantises. Manchester hopes these fossils and others like them will come out of the Deccan Traps will help illuminate the distribution of species at a critical time in Earth's history. That is really cool. And again, we'll also link And we'll link that. Well, it's found in there. Whoa. Analysis of a 30,000-year-old fossil vulture from central Italy has revealed for the first time that volcanic rock can preserve microscopic details in feathers. Yeah, look at that. That is pristine. International team discovered a new mode of preservation of soft tissues that can occur where animals are buried in ash-rich volcanic sediments. The new research reveals that the feathers are preserved in a mineral phase called zeolite, a mode of preservation of soft tissues never reported before. The fossil vulture was found in 1889. The entire body was preserved as a 3D impression with fine details such as eyelids and wing feathers. What is zeolite? Whoa, look at that. Interesting. Zeolite preservation. Oh, look at that! NIH. We love the NIH. Fundamental properties and sustainable applications of the natural zeolite clinoptilolite. This review explores a set of sustainable applications of clinoptilolite, a natural zeolite abundant around the world in different localities. We will look at that later. That is not what we're reading right now. Zeolites are mineral rich in silicon and aluminum. Oh. They can form as primary minerals or can form secondarily during the natural alteration of volcanic glass and ash. Oh. The alteration of the ash due to passage of the water induces the precipitation of zeolites nanocrystals that in turn replicate the feathers to the tiniest cellular detail. Oh. So I wonder, because, I mean, a lot of people talk about the meteor that struck the Earth, wiped out all the dinosaurs, and we just read about volcanoes that took out the other part of the dinosaurs where the meteor wasn't immediately present. So, putting two and two together, it is very likely that there are many other yet to be discovered fossils that are preserved in this zeolite fashion, since it says, right, was entombed in a low temperature pyroclastic deposit. Which, what is pyroclastic? Just so that I understand what words I'm saying. What are pyroclasts? So let's look at Volcano World again. Oh, it's tephra. Okay. We learned about tephra. We know what tephra is. Okay. So they were in a low temperature deposit. So that tephra that fell, it was the ash. It formed into this zeolite. Surely, like this was a vulture. This was not a cave-dwelling creature or anything. Surely, there have to be some well-preserved dinosaur fossils from either the volcanic eruptions or when the meteor struck. Like, you know? Because when was this written? When was this written? Oh, goodness, last year. Heard. Okay. So this is very new. This is a very new discovery, all things considered. So surely there have to be some of these fossils that are preserved in similar ways. And by doing so, we can look at dinosaur records from the past and update our knowledge of them. Like, you know what I mean? Like, if it was such a widespread event, if it was so big that it wiped out literally an entire world of ecosystems and creatures and fauna and flora, then surely there have to be some that were preserved in a similar way as this. There must be. This one is 30,000 years old, which the meteor struck like what, millions of years ago or something like that? I don't know. There has to be a decent portion that fell in a similar way. If an entire world has disappeared or was wiped out, they can't all have been wiped out in the same way. Right? Like, they can't all have been preserved in the same way. So surely there are some like this from that time period. There have to be. That's really cool, though. That is super, super cool. And then the lava tree mold fossils. And then the last thing we'll look at, we've got 3 minutes left. We will look at there we go. The British Geological Survey. This will be the last thing we look at with 3 minutes to spare. Volcanic eruptions are dramatic events that attract attention. Here's some of the main reasons why people live alongside volcanoes. 1. Volcanic environments can be good locations for farming. Why? They're enriched in elements such as magnesium and potassium. Oh. And then the rain comes and there's weathering and then the elements are... Oh. Thin layers of ash can act as natural fertilizers. Okay. In response to frequent eruptions, some farmers have adapted their crops and farming styles to suit different types of ash. That's cool! Volcanic deposits, particularly ash, are also quite porous, retaining moisture longer than many non-volcanic soils. Land close to a volcano is often good for agriculture. You would think the opposite for a lot of things, right? Because the fire and everything else, that's cool. Eruptive products and the forces that produce them shape the landscape, sometimes removing land and sometimes adding to it. For example, in 1973, the volcano of Eldfell on the island of Himei erupted. Himei has Iceland's only harbor in the south of the country, and for a few months it appeared that it would be destroyed. However, when the lava stopped flowing, it had increased the land area by over 2 kilometers. That's cool. It actually enhanced the shape of the harbor. Cool! Volcanic environments often evoke a strong sense of place. Huh. That's cool. Volcanic communities have a very strong bond with their volcano. Volcanic environments are simply just home for many people. And then tourism. Volcanic environments can produce rich mineral or metallic ore deposits. Oh, that's fair. A country of Cyprus, which roughly translates to copper, owes its name to the mining of copper deposits. This copper occurs in parts of Earth's crust that have been pushed upwards. Long ago, seawater circulated through the volcanic ocean crust and was heated up to 350 Celsius. This heated water became acidic and corroded the rock, which it was flowing, becoming enriched in elements such as copper. Oh. Many countries with active volcanoes are able to use the heat as geothermal energy. Water in the upper crust is heated above a magma chamber. This is often apparent on the surface due to the presence of hot springs or geysers. Pressure builds up when the boiling water is trapped beneath a dense impermeable rock layer, such as clay. By drilling a deep hole through this layer, the steam rises to the surface and expands, either driving turbines or being directed through heat exchangers. And that is our timer. Practicality, coercion, and references. Cool! What did you guys learn today? I learned a lot, actually. I didn't think I would learn a lot. I learned quite a bit. What did you guys learn? I hope that people are still here. Well, either way, it has been a pleasure as always to be with you guys, to learn alongside you guys, and hopefully this was fun for you guys. This was fun for me. I will be seeing you guys on Monday. We're going to do Subnautica again. I will post this video. It will probably take like 2 or 3 hours because I'm going to try to draw a thumbnail for it again like I did for the last Fun Fact Friday. And when I do, I will be posting every single one of the links that you have seen today. So you guys will have full access to this. This is something that anybody can access. So it is all free and readily available. And yeah. So hopefully you guys learned something. Yay, King, you're still here. Awesome. No, you're good. You're good. But I am going to go ahead and... Yay! Learning! We love learning! Yay, I'm so glad. Well, I am going to go ahead and call it a day. I will release this video. And you guys will have access to all this if you want to read more into it. But yeah, I will see you guys on Monday. Bye!